Hey everyone, Robert Gloria here, Open Up Resources 8th grade community coach. And I just wanted to give you a little overview on the 8th grade Unit 4 so that you know exactly what to expect in this unit, so you know what are the major concepts we're going to hit, how to support students, and also the progression. So so we're not over teaching, which I think is a critical component of the Open Up Resources curriculum. Just understanding, what it is we're teaching them in each lesson and how it kind of unfolds throughout the unit. And so Unit 4 is linear equations and linear systems. Okay, so if you recall, or if you're currently in Unit 3, this is linear relationships, where they're focusing on the formula y equals mx plus b, looking at the y-intercept and slope in particular. Well, here, what we're going to do is in this unit, they're mostly, so the unit is can be cut up into two major pieces, I would say. The first half of the unit is where students are going to be solving equations, okay? And in this case, they're called linear equations. But the important thing to note is that they are solving linear equations with one variable, okay? So the equations have variables that are on both sides of the equal signs, and equations with no solutions, one solution, infinitely many solutions. And so as a result, students are really going to be tapping into the knowledge that they learned about equations in 6th and 7th grade with the curriculum. And so it starts off with lesson 1 is number puzzles. So it's a really friendly lesson. I love it because it's just a great way of inviting students to just have fun with puzzles. And then there's a little bit of algebraic thinking in there, but it's not really that explicit, because as you can see, they're using line diagrams and tape diagrams. And if you look at the lesson itself, and we go to the cool down, right? It's they're using tape diagrams. Okay, and they're supposed to find Lin's error with this. Okay, so again, there are some algebraic components, but it's mostly just tape diagrams. And we also have in the warm up here, okay, we have number lines. And so this is great because, students, like I said, my students enjoyed it, and they really participated in it. And it's just a great way to just kind of start it off. And then lesson 2, they're introduced to, or they're reintroduced to, this hanger diagram. One of my students, when we were doing this lesson, the student was like, hey, I remember this. I've seen this picture before. And it turns out that this picture does appear in 6th and 7th grade equations and expressions units and Open Up. And so it's a really great thing that, they can connect with it and just jog their memory. Now, the really important thing about this, I mean, obviously this is where they're going to introduce the idea where the equation is balanced, and this one is of course not balanced. And so again, really inviting, and students have to kind of explain why this is not balanced, why this one is. But if you look through the lesson, it's just going to kind of start to connect these blocks with, being in balance. And so it's a really cool way of just reintroducing the idea of a variable, okay? Because as they work, they're going to see that sometimes they're given values for the shapes. Other times, in some cases, they're not. And so in the cases where they're not given values for these hangers, the students, have to kind of just apply an X or a variable to it. And so it's a really cool way of introducing it. The idea that okay, look, if I take a square off the right side, I have to take a square off on the left side, right? Because this idea of keeping it in balance. Now, this is a concept that is introduced here, but it's also going to be a really critical concept as they move through solving equations throughout this unit. Lesson 3 goes into where it starts to connect the shapes to actual variables and numbers, and that's when they're gonna start to actually build equations. Now, just a bit of a heads up here. When they're solving equations, as I said in the description, it's not like x plus 5 equals 10. So, it's not it's like a one-step equation. These are multiple step, and a lot of these equations, they get really large and complicated, and there's this distributive property is thrown in, lots of negative numbers. So that's the one thing that you should really be thinking about in the first part of this unit is, okay, how am I going to support my students as they're working on, solving these equations? I'll start with, let's balance moves so you can kind of see the equations they start with. Okay, so here, this is the warm up here. Okay, as you can see already, I mean, these are pretty large equations, right? And they have numerous variables. And so here, the concept that should really be driven home is the idea of combining like terms, right? If you can combine the like terms, you should do that. But they're starting to solve equations now. Okay, and it's really interesting how OpenUp does it, because instead of going straight into the solving, it's kind of more looking at it more strategically, like, hey, what kind of move can I make on the left side and then do the same thing on the right side and keep it in balance. And so just a word of caution here, it's definitely easy to start over teaching here, okay, but these lessons are mostly just looking at steps that like Noah took, for example, and Lynn took, and then they have to say if they agree with them or not. And in the next few lessons, they're actually finding errors that students make, or they're explaining what moves that were made. Like, for example, here, they have to be able to say, oh, well, Noah used the distributive property in order to get to 2a and minus 6. Whereas here, they're going to have to notice that Lynn avoided the distributive property, right? And just divided everything by 2. And so, some teachers might be like, wait, what? That's kind of weird. Or you might get a little frustrated that it seems to be going slow. But again, the idea here is that you have to keep the equation in balance, and you also have to do on the left side, whatever you do on the left side, you have to do on the right side. So that's those are the two major components that they're really practicing here. And great opportunity to review the distributive property. I know a lot of my students really struggled with the distributive property, remembering what the step was, remembering that you're multiplying. A lot of students were trying to, like, say a minus 3 is 2. They were just having a hard time with that. So that's the other thing is, like, although these particular equations I'm showing you here are relatively short, okay, there are quite a few concepts that are taking place here. And so you want to remind students of, first of all, like, combine like terms, like a minus 3 cannot be combined because they're not like terms. So that's one skill that you're really going to need to be aware of as you're teaching this, because again, students may not remember that. So for me, I put on an anchor chart, like, hey, these are just review. These are the skills that we're going to be practicing. And then, of course, the distributive property on the anchor chart, showing them the steps for the anchor chart. And then, it's really nice to just start getting into, well, what are they doing here? And then you can start talking about, well, when they isolate the variable, that's how you solve the equation. And so the goal here is you're making moves on both sides strategically that are going to eventually get you to the answer, right? And so that's another skill that they're going to have to know is how do I eliminate like the A on one side, and then how do I eliminate this 12 in front of the A? So again, I lay these steps out on my anchor chart very specifically so students can remember what the steps are for solving the equation. So this is a great opportunity where they don't have pressure to actually solve the equation themselves, but really just take that time to point out the structure of the equations and just trying to get them to understand what exactly is happening. Here, a lot of my students did well with this one, cool down. They have to just match the steps with what happened from here to here. And so again, a lot of processing, but at the same time, they're evaluating these steps and they're realizing like, oh, hey, there are some strategic ways to get rid of a fraction, for example, in an equation, or as we saw in this example, avoid the distributive property. And so that continues on for 4, 5, and 6. Okay, and so those are the major things that eventually, when they get to strategic solving, that they're gonna start solving the equations on their own. But again, just a word of caution, not to overteach. Where we're starting off just looking, observing how other students, make-believe students in these cases, are solving equations and just trying to understand like what they're doing, how they're doing it strategically. And then the next major concept that appears, they're still solving equations, is all sum or no solution. So this idea that it's not always just going to be one solution. In some cases, it's going to be all or none. Okay, and so in this case, students will start to comprehend that, if you have n equals n, well, you can put any number in that equation for n, and it'll always be true, because if n equals 0, 0 equals 0, 1 equals 0, 1, and so on and so forth. And so here they're just kind of starting to understand those rules, differentiating between like this is 2t plus 6. This is also 2t plus 6, but of course they have to distribute to see that. And so they're just learning those rules, where the way I phrase it is just like, hey, look, if the coefficient and the variables on both sides is the same, but and the numbers are also the same attached here, being added or subtracted, then we can say that it's all solutions, and we explain why. However, if the coefficients and the variables are the same and these numbers are different, then we're going to say it's no solutions. And so it's just teaching them that rule, reinforcing that rule, and then of course OpenUp provides sufficient practice and encounters with different versions of equations. Of course, some of them do get complicated here with the fractions, and we just have to go back to, if you want to get rid of the fraction, like how are we going to do that? What are we going to multiply by? What do we need to divide by? Okay, so this is kind of early on. So by the end of this lesson, they should be able to put in an 8 here for all values, or a different number, maybe like 6. For no values, and then 1 value. This is where you really drive home that point, where the coefficient of the variables has to be different, and the number also has to be different for that to work there. So that is all sum or no solutions. That continues on to 8, okay, where they're kind of looking at some other situations and just trying to figure out how many solutions there are. So this number 8 is a lot more practice with that. Now, so 1 through 8, again, just to summarize, it's just introducing them to the idea that you have to keep an equation balanced, and to do that, you need to make moves on both sides, isolate the variable to find the answer, and sometimes there's all or no solutions to to the equation. And now 9 is where the second major part of the unit comes into play, and that's the systems of equations. Okay, systems of equations, it's really cool because the way that it's done here is it's taking what they learned in the unit 3. They just learn about linear equations and relationships, and it's basically combining that with the first half of this unit 4, we're solving equations, because they have to be able to put the linear equations together to form a system of equation and then solve it. And so it's really, I love it the way that it's designed, because the linear equations is still fresh in their mind. And what I do is I take the anchor chart out from that unit, just remind them y equals mx plus b, little review what that means. And the kids are able to really take off with it. And so these are two concepts that are really still fresh on their minds. And so we start off with this question of, again, very inviting. What rate would you rather have if you're babysitting? And the kids come up with some really great answers. Sometimes the students actually get the exact answer, where it's like over 6 hours, and one is better than the other. I think it's this one is better than this one. But it just creates great dialogue. And then what I do for this one is, after we're done with this warm up, to really drive that point home that, hey, we're actually going to be combining our lesson from before. What I do is I just actually write this in linear equation format. So it'll be y equals, and then 8x. X will be representing the hour, and then plus 5. Okay, and then this is like, for my students, this is really all they needed to remember, like, oh, hey, I know exactly what that means. And it was just amazing to see how much they really remembered from that previous lesson, previous unit, I should say. And so for this, you ask them, well, what does the X mean? And then I asked them, well, what does the Y mean? And it takes them a little while to figure it out, but then they're like, somebody comes out, oh yeah, the Y is the total amount of money. So X must mean it's the hours, because that's the thing that's changing, right? And they get excited because they remember it. And so he's like, yeah, that's it, right? You got it. And then what I do from there is I get rid of the Y, and I set this part equal to this part, and I just write it on my board. And then I say, well, look, let's solve it. And then I remind them of the steps of solving. And, I ask them what I do, and they walk me through it. We do it together. And then, we come out with the answer, which is 5. And then we talk about that. We say, well, what does the 5 mean, in this context? And then they really just get a really deep understanding. But also, I've just modeled for them how to form a system of equations. And so I make that really explicit at this point, like, hey, this is how we're doing it. And so it's a really great introduction. Then we go into water tanks, where it's, again, very inviting. There's just tanks, and they just have to explain what's happening, estimate when the two tanks are equal. And of course, like, they get close. Some of them actually get the exact answer, which is 19.5 minutes here. But the students realize, after they do 2 and then we do 3, I say, okay, look, here's 2 linear equations, set them equal to each other, and you're going to find the answer. Once they realize they could do that, it becomes clear, like, hey, if I set them equal and make a system of linear equations, well, I don't have to estimate. I can get the exact answer. And so the power of the system of equations really becomes clear to them in this lesson, and it's really great. And then you go on to graphing. So I know, when we were on school, there was a lot of different ways to solve systems of equations. Just so you know, here we're focusing on the graphing component, and we're focusing on the substitution method. Okay, so again, trying to avoid over teaching. Everything is designed for those methods from 9 to 16. And so we don't need any other method. Okay, so we should definitely stick with the graphing method and the substitution method. And that's pretty much all we're going to need. We don't need the other methods for this particular unit on systems of equations. So of course, this one is going to be graphing, and then they're going to get into solving systems of equations, you know, getting to to figure out, well, if I have two linear equations, okay, I can use the graph to figure out which one is which. Okay, so that's solving with the graphing method. And then here in the cool down, well, they're parallel, so they're not going to meet, therefore there's not going to be any solutions here in this case. So and then that's great because you're connecting it back to like, oh, this is what it looks like when there's no solutions for two linear equations. And so you really develop that language, and then you get to solving more systems, whereas this one is starting to use the substitution method. Okay, so let me go back here so you can mark that down. Lesson 14 is the very beginning of the substitution method. Okay, the lessons 10 to 13, we're dealing with the graphing method for solving systems of equations. Here we're doing solving more systems. And so this is where they realize. And I really love how OpenUp does this, because it's like, you know, in the old days, just have a bunch of practice. But in this case, there's, you know, several different options, and then the kids have to rank them least difficult, most difficult. I find that to be a very useful activity for students, because they really think deeply about them. And you'll find that, you know, students will have a different list for the least difficult than, you know, their group members. And that's what we want. You know, we want to see that variation. Some people may say, oh, the 3/2 is very easy, right? And whereas other people it's like, no, that's a hard one, right? And so we want to see that variation. But in this case, it makes it very easy for the substitution method for like this one, for example, y equals 4. You know, you just plug in the 4, y equals 7 here. And so some of them are much easier than others. Okay, and so they're able to kind of figure that out. And then for the cool down, they're going to solve it from here, given the two equations. And here are the possible responses. And so again, substitution method all the way through from 14 on. Okay, so that is unit 4. I know some people were asking for, you know, just some questions about this unit, or just a little bit more guidance. So I hope that this video was helpful for you. And again, you know, if you have any questions, feel free to ask in this post. Thank you very much, and have a great day.